Hello everyone, this is P. Hemant Kumar. Our project title is Pneumonia Detection Using Deep Learning. Our teammates are G. Naveen Kumar, Y. Nitin Reddy, and myself P. Hemant Kumar. Our supervisor is Dr. M. Kavita Ma'am. Agenda we have abstract, objective, introduction, literature review, design and methodologies, implementation, conclusion and references. Abstract. In this era of COVID-19, proper diagnosis and treatment of pneumonia are very important. Chest X-ray images analysis plays a vital role in the reliable diagnosis of pneumonia. An experienced diagnostic required for this. However, even for an experienced radiographer, it is quite challenging and time-consuming. Uh, Hence, an authentic and automated system can play an important role here. In this era of cutting-edge technology, deep learning is highly used in every sector. Chest radiography is a significant diagnostic tool used to detect diseases afflicting the chest. The detection techniques associated with computer vision are being adopted in medical imaging research. Various automated systems have been proposed for the rapid detection of pneumonia from chest X-rays. Although several algorithms are currently available for pneumonia detection, a detailed review summarizing the literature and offering guidelines for medical practitioners is lacking. Objectives. The main aim of the project is to detect the pneumonia using deep learning techniques. The scope of the project is to develop a pneumonia detection system that will reduce the workload of radiologists using CNN. Introduction. The inflammation of a lung due to virus, bacteria, or fungi attack causes reduced oxygen level in the blood. The associate editor coordinating the review of manuscript and approving it for publication was Cao Tong, scream, and chest pain when breathing. It fills the alveoli of the lung with fluid. It ranges from mild to severe and requires patient to be treated in the hospital. Symptoms like pain with breathing, fever, shivering, cough with pus, lack of appetite indicate pneumonia. In recent times, these symptoms also indicate COVID-19. Therefore, it is a crucial visit to the doctor to identify which one among pneumonia is COVID-19 and normal cough based on identification. It should require rapid treatment. People of any age can be affected by pneumonia, but children aged less than 5 and older people more than 65 years are more likely to be affected by pneumonia due to their weak immune system. It is the prime reason behind the death of children aged less than 5 years on a global scale, and death rate is around 95% in developed countries. In 2015, around 17,850 died from pneumonia among the total deaths of 1,19,000 children who are aged 5 years and less than in Bangladesh. Around around three children die every hour, 67 per day, and 24,300 per year in Bangladesh. However, for a human to diagnose and correctly recognize pneumonia using the CXR images is a time-consuming and quite challenging task. The CXR images are sometimes unclear and fuzzy, which drives an erroneous detection. To reduce the number of deaths, a trustworthy diagnosis system is required. In this modern technological era, machine learning performs a great role in automatic detection diseases such as heart diseases, breast cancer, and brain cancer. Literature review. These are the literature review. Design and methodologies. System design. CNN are a class of deep neural networks that can recognize and classify particular features from images and are widely used for analyzing visual images. Their applications range from image and video recognition, image classification, medical images analysis, computer vision, and natural language processing. There are two main parts of CNN architecture: a convolution tool that separates and identifies the various features of the image for analysis in a process called as feature extraction; a fully connected layer that utilizes the output from the convolution process and predicts the class of the image based on the features extracted in previous stages. The network contains 6 convolution layers and 3 max pooling layers. Convolution layer contains 32 filters of 3 into 3 pixels. Railway activation function is used in these convolution layers. Finally, two fully connected layers and two dropout layers are added. As the current classification is binary classification, we use sigmoid activation function. Loss function used in the network is binary cross entropy, and optimizer used is Adam optimizer. Uh, Module 1, Image Preprocessing. The dataset mask phase recognition collected from Kaggle contained a lot of noise, and a lot of repetitions were present in the images of this dataset. Since a good dataset dictates the accuracy of the model trained on it, so the data from the above specified datasets were taken. They were then processed, and also all the repetitions were removed manually. The data cleaning was done manually to remove the corrupt images from the said dataset. Finding these images was a vital part. As it is well known, the correct images was a tricky task. But due to valid efforts, we divided the work and cleaned the data with the pneumonia images and without pneumonia images. Cleaning, identifying, and correcting errors in the dataset removes adverse effects from the predictive model. In pre-processing step, the images is transformed into grayscale images because the RGB color image contains so much redundant information that is not necessary for face mask detection. RGB color images store 24-bit for each pixel of the image. On the other hand, the grayscale image stored 8-bit from each pixel, and it contains sufficient information for the classification. Then we reshaped the images into 64 into 64 shape to maintain uniformity of the input images to the architecture. Then the images are normalized, and after normalization, the value of pixels resized in ranges from 0 to 1. Normalization helps the learning algorithm to learn faster and capture necessary features from the images. Pneumonia detection. The model build used is the sequential CNN model with various layers such as conv 2D, max pooling 2D, flatten dropout, and dense. In the last dense layer, we use the softmax function to output a vector that gives the probability of each of the two classes. Here we use the Adam optimizer and binary cross entropy as our loss function, as there are only two classes. Module 2, Convolution layer. This layer is the fundamental block of the convolution neural network. This term convolution implies a mathematical combination of the two functions to get the third function. The kernel is spatially smaller than an image, but in more in depth. This means that if image is composed of 3 RGB channels, the kernel height and width will be spatially small, but the depth extends up to the 3 channels. During the forward pass, the kernel slides across the height and the width of the image, producing the image representation of the receptive region. This produces a two-dimensional representation of the image known as the activation map that gives the response of the kernel at each spatial position of the image. Filters, convolution kernels. A filter is an integral component of the layered architecture. Generally, it refers to an operator applied to the entirety of the images, such as it transforms the information encoded in the pixels. In practice, however, a kernel is a small sized matrix in comparison to the input dimensions of the image that consists of the real valued entities. Module 3, Max Pooling Layer. Applying the pooling operations can make calculations go faster by allowing a reduction in the size of the input matrix without losing many features. Max pooling is taking the maximum value present in the selected region where the kernel is currently at the value for the output of the matrix value for that cell. Dataset. The dataset that we used and processed by previous works had their worth discussed below. Kaggle dataset. Kaggle is a website that allows user to use their dataset, work on it, and explore it for the future research. In this dataset, there are three folders named train, test, and val as well, and their subfolders contains two types, which are normal and pneumonia images. Implementation. In implementation, we have architecture diagram, data flow diagram, use case diagram, class diagram, activity diagram, and sequence diagram. This is the architecture diagram. This is data flow diagram. This is use case diagram. This is class diagram, and this is activity diagram, and this is sequence diagram. And finally, these are the references. Conclusion: in the last few decades, pneumonia has been one of the significant causes of death for children and old age people. Patients with pneumonia who are diagnosed early have higher chance of surviving. Recently, detection of pneumonia using CXR images have been performed by the researchers. The detection rate is accurate. It can aid the medical practitioners in quickly diagnosing the disease and save the patient's life. In the first phase, the image quality has been enhanced using clay. After applying clay, the most prominent features have been extracted finally. A CNN model have been proposed to detect various types of pneumonia from these extracted features. In the future, the authors have planned to create a web app where this proposed method will be implemented. CXR images can be uploaded to the app, and pneumonia will be diagnosed automatically. It has also been planned to investigate how the proposed model will react with the increased data set size. Thank you.